So in our class, we are going to consider our numeric and geometric patterns as an introduction to what you're supposed to be working with according to your syllabus or according to your annual teaching plan. We have got this part of our numeric and geometric patterns. So we are going to first consider or work with the numeric patterns, which is simply referring to the number patterns. So, guys, as we are given the numeric patterns, we are simply referring to the number patterns. That is the major part that you're going to have. Then we are going to be, then we are going to talk about the geometric patterns, which is where you'll be working with the diagrams. All right, in that part, they will give you a certain table or a diagram too. There will be diagrams in form of diagrams, same number patterns, guys, that you are given, same presentation that you had, but only that it will be in form of what? In form of diagrams. So that is the major part that we are going to have. So, guys, it's nothing at all. What you just need is to make sure that you go through all the classes that you're going to have, and also the exams. We are going to work with question papers after that so that you see how questions are being given or how are they being asked in your question papers or the ones that you expect to have at the end. All right. So like I said, guys, we're going to be focusing with the numeric patterns in this case, which is the part of our number patterns. It is simply a presentation of a sequence of numbers that follows a rule. It is simply is a sequence of numbers, a sequence of numbers. So I want us to see this part, a sequence of numbers that follows, all right, that follows a rule. All right, if you take this part of a rule, you consider we had this in our grade 8. Remember when you're talking about those input and output values, you were having input and output values where you insert values of X, then you get the output. It is the same thing that we are having here. We are saying under our numeric patterns, we are just given these numbers forming a pattern or a sequence, which we are supposed to tell whether there is a common difference, there is a common ratio, or what. So any sequence that you're given can be of addition, subtraction, multiplication, division. But what I want you to understand is that you'll be given, let's say we've got numbers 1, then we have got 3, all right, which is followed by 5 like this, which is followed by 7 like this. This here is a sequence, but the sequence that we are given of numbers is going to form, or it is going to give us a certain rule that it follows. How are we going to tell? We just need to ask ourselves to say, from 1 to this number, which is 3, what happened here? What is it that we did? Are we going to add? Are we going to subtract? What actually happened from this one to get a 3? What happened from 3 to give us a 5? From 5 to give us a 7? This is what you're asking yourself. That is the condition that we are going to be talking about to say there is a sequence. But what is happening from one to another? All right. So for us to understand this, we just have two conditions, guys, that we are going to be working with as we have our syllabus. We are just going to have two conditions. So in this class, we are going to work with the first condition where you form a number pattern, all right, or the one that I was showing you there. You form something like that, a number pattern with a constant difference. So we're going to focus a number pattern with a constant difference. With a constant difference. All right, with a constant difference. So I'm just gonna call the constant difference D in short, constant difference. So we can be given a number pattern that has, or a numeric pattern that has a common or a constant difference. A difference we're talking about in between the numbers. In between, let's say we are given 5 like this, another number that is following is a 7, another number that is following is a 9, another number that is following is 11. These are numbers that are going on, going, but they are following a certain rule. So we have to ask ourselves to say, what is happening here? I want you to see. If you check from 5 to 7, there is a difference of 2. From 7 to 9, from 7 to 9, there's a difference of 2 again. So let's say we call this one T1 to represent the first term, like this is according to the order 1, 2, 3. So this will be our second term, this will be our third term, this will be our fourth term, and so on until you get the last term. So I just want you to get the idea of this type of a number pattern with a constant difference. For you to obtain that difference, you simply subtract. As you can see, guys, there's a difference between these two numbers, 7 and what? And 5. So you subtract 7 minus 5. You are, remember, guys, as you are moving, you're going up. You're going to the what? More positive. The numbers are going up. So we just need the difference. Say we started here, we are now at this point, we are now at this point. So the difference now, we're supposed to be where we are minus the previous stage that we had. Where we are minus the previous, that is the case. In that manner, we can have the difference, this one, the constant difference, which is the same from constant. We are saying it is the same even in between the 9 and the 7, even in between the 11 and the 9. What is that difference? We're simply going to subtract T2 minus T1. That's 7 minus 5. The difference, 7 minus 5, which is 2. 9 minus 7, which is 2. 11 minus 9, which is 2. So as we can see, guys, the difference there is the same throughout. So it's this one minus this one. This one minus this one minus this one, like that. So that is the condition of finding our D. Second term minus the first term. Or you can use third term minus the second term, whatever order that you want. So are we seeing from the second term to the first term we are subtracting? From here to here we are subtracting. So what does it mean if we are moving from here to here? There we had to subtract. Remember, we're subtracting. So my question is, guys, what about moving from this 3, from this 5 here to this 7, from this 7 to this 9, from this 9 to this 11? What is going to happen? We are simply going to add. This time we are adding from, we are going forward. We are adding. So we add a 2, 5 plus 2, that's a 7. 7 plus a 2, that's a 9. 9 plus a 2, that's 11. So it means that the common or the constant difference, this one, is to be added to obtain the next term. The next term. Okay, so to obtain the next term, add, we're simply going to add what? The constant difference. Add constant difference. As we saw in our question, we had to add 2, 2, 2 up to the next one. So it means with this idea, guys, you can even find another term that is following here. Simply 11 plus 2. That's what? 13. Another one plus 2, which is 15. Another one plus 2, which is 7, and so on and so on. We can find these terms like that. Once you know the common or the constant difference, you add from the previous term to obtain the next one, and so on and so on and so on. That is the idea of what is happening there. So what is it that they're going to ask us? They can ask us to find these next terms. You just have to add what? The constant difference. They can ask us to determine the general rule on this number pattern with a constant difference, or a numeric pattern with a constant difference. They can ask you there to calculate, or to determine actually the general rule. So to determine the general rule on this one, the general rule, it is just a relationship, guys, which shows us what is happening between the given values input and output. Like I was saying in our grade 8, remember, you were having something like this where you've got input, all right? Then here we've got what? The rule, which will give us what? The output. So in our case, what is it that we are saying the rule or the concept? If you take it from your grade 8, you were saying this is what is happening, guys. When we say T1, we are saying in terms of the position, this is our first term. This is our first term. Okay? The first term, second term, third, second term, third, fourth, and so on. So these are number of terms. Number of terms, like nth term. Like we are talking about number of terms that we are focusing with. Say this one is the first one, second one, third, and so on and so on and so on. So if you were to give, let's say, using this concept, you were going to have a side where you have got what? The input, and another side, you have your output. So you're asking yourself to say, when you input like the first term, like we are saying, when n is 1, our general rule is in terms of n. So remember, you're talking about number of terms. So you talk about n. So you ask yourself to say, when n is 1, it enters the rule. Then what happens? We must get the output, where our output is the number that is representing the first term, which is what? Which is 5. The same thing for the second one. We are saying when n is entering as 2, it enters what? The rule. Then it gives us the output. And what is our output? The number which is there, which is 7. So do you see the concept of your grade 8 there? Input, rule, output. So how are you going to determine this rule? That is the same way that we are talking about, only that now we are working with a separate part that we are saying number pattern, but it is the same thing. So our rule is supposed to be in terms of n. This one, in terms of what? In terms of n. So it is found in terms of n, or to be calculated in terms of n. In terms of n. So how do we find our general rule? Guys, we can even study it. We can use the table. We can use those input output concept that we had before. But this is the idea there. We want to use this one, the example that we had here on top. We're going to use that one. So for an example, all right, for example, we want to determine what? The general rule. Remember, this was our sequence, or the number pattern that we're given: 5, 7, 9, 11, and so on and so on. So we want to know the rule that is creating this one. So under a number pattern with a constant difference, as long there's a constant difference, this is what you're going to do. Your general rule is supposed to be in this form. Tn is equal to, you are supposed to have a number here which multiplies n. Remember, I talked about this in our grade 8. A number which multiplies n plus a certain number that we're going to have here. So this is what I want you to understand about these two. This one that is here, we know it because it represents what? Our constant difference, the one that we calculated there. This is your constant difference. So you are supposed to put back your constant difference in here. This is your constant difference. Okay? Then this one that is here, the number that you're going to put there. Okay, I want us to be careful there. It is a number that is to be calculated. What must be added to give us the number in position? To say the first term, the number is 5. The second term is 7. So to give us a 5, to give us a 7, after you have put that constant difference here, what are you going to add or what are you going to subtract to give us the number in a position? This is what it means here. So this one, we can say, what must be added? So what must be added or subtracted, okay, to give us the what? To give us the number in position. To give us the number in position, in the given position. All right, or let us just say in the number in what position? In that specific position that you're working with. If you say it's position 1, position 2, position 3, you are going to have the same thing throughout. What must be added? What must be added to give us that? All right, so this is what I want us to do about this question. We want to determine the general rule, and this is our example here. As we saw, guys, from our example already, we got at our constant difference. Anyways, for the sake of revision, let us have our question in what? In a simplification. All right, so this is what we're going to have. Constant difference. There's a difference here, a difference here, a difference here, because we are saying these are our terms. This is your first term, your second term, your third term, your fourth term, and so on. Remember your difference. How do you find it? The difference between the terms. So we can simply use what? Like I said, second term minus first one. So you can even use a continuous one. The difference, guys, is this one minus this. That is the case. 7 minus 5, which is 2. 9 minus 7, 2. And so on and so on. You see, this is the difference, this one. You take that difference, okay? You put it here because we are saying our Tn is supposed to be given here. We are supposed to get it here. Here, this one. So let us find our Tn. This is how we're going to find our Tn. So we're going to say our Tn, which is our general rule, is equal to the constant difference here times n. Here, the whatever that multiplies n, guys, in mathematics, some of the things you just need to follow up, all right? Some of things you just need to follow up. So there is the number which is multiplying the constant difference which multiplies n. What is our constant difference? It is our 2. So this 2 is the one that we are talking about here, the constant difference, this one. This is the number that you're going to put here. So it's going to be 2n. Remember, we said we need a number here. So that number is what? Is 2. The constant difference. So what are we going to need, guys, is the number that is supposed to be added here to give us the number in position. So this is what I want you to understand. We are saying to give us the number in position. All right. This is what is going to happen. When we say a position, we say position 1, position 2, position 3, position 4. What represents the position is the n. So when you say position 1, n is 1. When you say position 2, n is 2. When you say position 3, n is 3. When you say position 4, n is what? N is 4. So this is it. So you're asking yourself, okay, you can even do it like this. Okay, let us have it here, guys. You understand me very soon. So you can do it like this. You can say for position 1, it means what? N is 1 for position 1. All right, n is 1. So it's going to be 2 times n position 1. Our n is 1. What are we supposed to add? What is supposed to be added to give us the number in that position? What are we supposed to add? This is the question. What are we supposed to add here to give us what? We are on position 1. Here, position 1. Position 1. What are we supposed to add here to get the number in position? The number in position is what? Is 5. This is the number in position. So what are we supposed to add here so that we're going to get a 5? So guys, this is what we had in grade 8. So just say, okay, is 2 times what? 2 times 1, which is 2. What am I supposed to add here to get a 5? This is your question. So we're simply going to take the 2 to the other side. So that will be 5 minus 2, which is 3. We're supposed to add a 3 here. By looking into this, we can see we are supposed to add what? A 3. What is supposed to be added here is 3. So it means the number here must be 3. But if you're not sure about that, prove again with another one. Use another one. Here we used what? The first position. Position 1. That was the first position. Position 1. All right, let's just say position 1. We substitute 1. Let's say we are at position what? Position 2. At position 2, it means our n is 2 here. N represents the number of the position there. Remember, I said n position. So it's going to be 2 times. What is our position? We are now at position 2. T2. Our position is 2. What must be added to this here? This is what we want. What must be added to give us the number in position 2? The number in position 2 is what? Is 7. So what must be added to give us that 7? All right, so you can even say 2 times 2, that's a 4. So 4 plus what? To give us a 7. What must we add here, or what must we put here to give us a 7? That's a 3. 4 plus 3, that's a 7. Or you can take 4 to the other side. So as we can see, guys, we have a 3 here, we have a 3 here. That is what must be added. It's what? It's a 3. Just like that. So this is our general rule. So you don't need to go through all of them. You just use one. You just use one. You have your general rule. You just use one. One, you ask yourself like this, the way that I was doing. Position 1. If it is position, any there, any is what? Position, any position here, this n. It is what? For the position. Position 1, position 2, position 3. So this will be our Tn for this sequence that we are given, or for this number pattern that has got a constant difference. Our Tn was going to be given as 2n plus what? Plus 3. So what does it mean? It means that we can find any term that we want, at any position. This is the rule, guys, which is used for any position. Okay, let's prove position 3. For position 3, or at position 3, at position 3, what does it mean? It means when n is equal to 3. When n is 3, where n is 3, that is the third term. What are we going to have? We are supposed to obtain what? T3. So how can we find T3? We can substitute n. Remember, n, this is the n for position. It is the same n here that we see. So if we say T3. What does it mean? It means here is going to be 2n. Our n is what? Our n is 3. We place that 3 there in place of what? An n. We place the 3 because we are saying third position, n is 3. So we substitute or we place that 3, then we can simplify, all right? 2 times 3, a bracket means times. 2 times 3, that's what? A 6 plus a 3. Remember your BODMAS. So let's add 6 plus 3, that's a 9. T3, the term that we have in third position is 9. Is that so? Let's go and check. Yes, third position is 9. So this rule, guys, can be used to find any term in position. They can ask you to find t when n is equal to 100. It means at position 100. We can substitute even here. T100. We can find anyone. T100. It means n is what? 100. So put 100 where you see n, like that. Then we must add a 3. So 2 times 100 is going to be 200 plus a 3, which is going to give you 203. Just like that. So that is the consideration that you must put whenever answering these questions. So let us quickly check some examples before we close up so that we're going to have another class for another type of a numeric pattern. So take note, this one that we are dealing with, or the type of a sequence that we are dealing with for this class, is of the constant difference. On this example, we are given 6, 10, 14, 18, and so on and so on. Is a given what? Sequence. So we are given a sequence there, which is 6, okay, followed by what? 10, the next term, which is 14, and 18, and so on and so on. There are so many terms that are following there. So we know that this is our first, T1, this is our second, T2, this is our third, this is our fourth, and so on and so on. All right? So the question was, A, state the rule in words. State the rule in what? In words. All right, to state the rule in words, guys, it is a condition just like what we saw here, to say from this number here that we have, from the first term to the next one, what is happening? We are adding 2, we are adding 2, we are adding 2, we are adding 2. This is the condition. There's a constant difference of 2, remember. So from that term to another one, we add. We start with what here? It's like start with what? Start with 5. All right? We started with 5. So we start with 5, add what? 2 to get a 7. So we add 2 to get a 7. What's going to happen? Add 2 to get this. This is what was happening here. This is having it in words. State the rule in words. So here, tell us what is happening from here. If we start with 6, because we're going to say our 6 is our first term, T1. First position, second position, third position, fourth position. So we are saying we're going to start with what? With the 6 as our first term. So start with the 6. So in words, so we're going to start with what? With the 6. But what is happening from 6 to 10, from 10 to 14, from 14 to 18? There is what? From 6 to 10 to 14 to 18. What was happening? There is a constant difference if we check properly between these two numbers. 10 minus 6, there's a difference of 4. 14 minus 10, there's a difference of 4. 18 minus, there's a difference of 4. You can even see by just looking on the numbers, you can know, guys, there's a difference of 4. All right? So you start with what? With the 6. Add what? Add 4 to get what? to get this term. The next term, remember I said from T1 to 2 to go there, you must add to go there. But to find the difference, you must what? Subtract T2 minus T1. So we are saying we're going to add 4 to get what? Add 4 to get 10. This next term, which is 10. So this continued again. From 10, we added a 4. We are simply adding a 4, adding. So where are we going to end? So we continue adding 4 to each previous term to obtain the next term, which is the consecutive terms. All right, so that is how we can conclude to say continue. All right, so continue adding what? Adding 4. Continue adding 4. The constant difference, you continue adding that to each previous term. All right, to each previous term. To each previous term to obtain the next one or the consecutive terms. All right, to obtain consecutive terms, then that is following each other, that's consecutive. All right, to obtain these consecutive terms, they will be following each other from one. We are just following like that. We are simply going to add 4, 4, 4, 4, 4, and so on. Just like that. So I want you to do as many questions as you can. All right, let's consider part B. On part B, they are asking us here to, what is the constant difference already? That constant difference is the one that we saw that we've been adding. Remember we said we're going to add the 4. We're going to add the 4 throughout. So that is our constant difference. It is already there. It is already there. Or if you want to calculate, you can calculate your constant difference. Remember I said you can subtract now term 2 minus term 1. This will be term 1, term 2. So term 2 minus what? Term 2 minus term 1, which is 10 minus 6, which is what? Which is 4. Same way, you can use term 3 minus term 2. You can use term 4 minus term 1 minus term 3. Just like that, you have your difference. So that was our constant difference. On C, we are being asked, write down the next 3 terms. The next 3 terms. From here, what will be the next 3 terms? Guys, remember the concept. We wrote this in words, that from one term to another, what are we going to do? We are going to be adding a 4. Remember, that was our A in words. We said we're going to be adding 4. So from where we are here at 18, we're going to add a 4 to get a next term. We add a 4 from where we are. That is the condition. So the next term there is going to be what? 18 plus 4. Where are we? At 22. So we'll be at 22. This is the next term. Followed by what? At 22, if we are at 22, what are we supposed to do at 22? We are supposed to add a 4. We are adding a 4. That difference to get the next term. So 22 plus 4, that will be what? 26. We add a 4 again. We need what? The next 3 terms. We add a 4 there. 26 plus 4, what are we going to have? That's a 30. So these are the next 3 terms that we are seeing. This one. From this sequence that we are giving, we're going to have 22, 26, 30. The next 3 terms. Just like that. Then on D, determine the general rule or the nth term. Guys, using a table, this and that, that's a long way, guys. I said, for you to have that general rule in easier way, we can use this concept here. Our Tn is equal to this concept, constant difference times the position plus what must be added to give us the number in position, in that position, to give us the number in that position. So we saw that is going to be Tn is equal to what? What are we going to use here to multiply our n, and what are we going to add? So we said the first part here, is your constant difference. This one is already there. This one, so it's our constant difference. This one, it represents our D. So you can even write Tn is equal to Dn plus, some they can say plus C, where they have to calculate this one. So what is our D? D here, this one. That's our D. Our D is what? 4. Our constant difference. So that's a 4 there. So we are supposed to ask ourselves here, what must be added here now to give the term in position? So if you start with the first one, let's start with the T1. T1 is what? T1 is equal to 6 here. T1. Meaning to say, guys, we are saying for n is what? Is 1. The first position. What must be added to give us the term in that position? This is the position. Our position, our n is 1. So what must be added to give us the number in a position T1? The number in a position T1 is what? Is 6. The number in that position is 6. So what must we add here? We just look, all right, 4 times 1, that's a 4, plus what? What must we add, guys, to get a 6? Here, that's a 2 here. 4 plus 2, that's 6. Or you can take this to the other side. But that's a 2. So the number that we need here to be added is a 2. If you do not know this, guys, use another part. Use another term. Let's go to the second, what we have at second position. So we're going to have 4n is, this one is just as it is, all right? So it's going to be 4 times n, when it is 2, we are talking about the second position when n is 2. That's our second position. What must we add to give the number in that second position? Because we are talking about the second one. The number there is what? Is 10. All right? 8. Here, 4 times 2, that's 8 plus what? What must we add to get a 10? Here, on 8, what must you add on 8 to get a 10? That's a 2. 8 plus 2, that's a 10. So as you can see, guys, the number to be added is a 2. This is exactly what we have. So there's no need for you to write all these numbers. Just use 1. If you work with first position, use first position. If you're working with second position, use second position. This number, guys, will be the same. This one, it will be the same for any position that you choose. So do not worry about that. So that is our general rule in this case. Our Tn is equal to what? 4n plus 2. So it means I can find any term. Like here when they're saying calculate, like this one on part E, calculate the 10th term. The 10th term, like the position 1, position. What is the 10th term at position what? Position 10. We are given the position in this case to say n is equal to 10. So what is the T of, what is the T10? Tn. So what is a T10? That is the condition. When n is 10, what about T10? You're just substituting, guys. You place position to get what is in that position. So it means T10 was going to be what? 4. In place of n, our position is what? Is 10. So that's 4 times 10 plus 2, just like that. You put back the value in the position, then you can calculate whatever that you want there. That is how these questions are being answered, guys. That's how these questions are being answered. You can answer as many questions as you can. So that is it, guys. We're going to have T10, 4 times 10, which is 40. Then 40 plus 2, which is what? 42. So the whole of this part was going to give us 42. Just like that. All right? The same thing even here on F. Calculate the 100th term. When n is 100, this is the case. When n is what? 100. What is going to be our T100? So T100 is going to be what? In place of n, put a 100. So that's 4 into 100 plus a 2 there. So you're going to multiply 4 times 100. which is going to be 400 plus a 2. So that's 402. So this is the case of our question, what we are supposed to have. All right, then another part, it was which term of the sequence is equal to? When they ask you by of the term of the sequence, the term of the sequence is the position. So they are saying which term? They are saying find any when the number in position is what? 242. The number in position, that's our T. We just take it like Tn. We just take it like Tn. The number in what? In position. The number in position is the one that we are talking about. So we let that to be Tn, 242. So we are saying when Tn is 242, what is the n, the position? What is the term? Which term of the sequence is equal? Which term? We're talking about the position. It's going to be at which position? Which position is that term? So find n. Remember, you're saying Tn is 242, but the same Tn is what? 4n plus 2. So this time we equate them. They are equal, these two. So to solve for any, or to find any, which is our position that we are looking into, we are going to solve an equation, because we are simply saying these two, they are equal. This is Tn, this is Tn. So what does it mean? It simply means also these two must be equal. You are forming an equation. So therefore, it simply means we are going to have 4n plus 2, which is equal to what? 242. Guys, you formed an equation that you need to solve for n. Remember your equations in grade 8, your linear equations. How do you solve? Take this 2 to the other side, it will subtract, or just subtract it both sides like this because they're positive. So subtract 2, that was going to give us what? 4n, 2 minus 2, that's a 0 there. All right. On this side, we subtract 242 minus 2. That is what? 240. So we're simply going to divide by 4. We're simply going to divide by 4 like this. That was giving us the value of n. Remember, there is a product. So divide the multiplicative inverse. So divide by 4 by 4. That's our n. So that is it, guys. That's going to give us a 60 there. 24 divided by 4 is simply a 6. Then into that 0, it's going to give us what? A 60, this one. So that's a 60, or you can simply use your calculator. So that is our n was equivalent to 60. The position where that is what? 60, like 60. So meaning to say it is T what? Remember, we say Tn. So if we say Tn and our n is 60, what are we going to write? T60 is equal to what? If we say the Tn, but our n is 60, it means T60 is equal to 242. That is 242 in position 60, in the 60th position. We have the number, which is called what? 242 there. So these are the typical questions that you might be given, but yeah, I just wanted you to know the basics of your numeric patterns, working with those ones with a constant difference. But guys, I thought we're going to even talk of using the table method. For those who are using the table method, continue, guys, with that method. Because of time, we need to have another class that is going to be concentrating on those number patterns with a constant ratio. There we're dealing with the constant difference. We're going to do another class where they have what? A constant ratio. So make sure that you watch all the classes and up to the end to understand this topic. This is it, guys, till we meet again.